This video is Circular Motion 3. Derive an expression for the speed needed by a satellite to orbit Earth at a distance of 3 RE from Earth's center. Here's a model of the Earth. There's its radius. Earth has a certain mass, and we're orbiting at a distance of 3 RE from the center of the Earth. From right there to right up there, that's 3 RE right there. And we want to know what the speed is. That's what we're after. When in doubt, it's a good idea to go to Newton's second law. Let's see if that gets us anywhere. The net force should equal the mass times the acceleration. All right. And we're dealing with the satellite. The satellite is the object. What is the net force on the satellite? The net force on the satellite is the force of gravity between it and the Earth. And so what's Newton's law of gravity? Newton's law of gravity is capital G times the product of the masses, which is the mass of the satellite, and then you've also got the mass of the Earth, and then we divide by r squared, the distance between them squared. Now, I'm going to write 3RE, and then I'm going to put 3RE again. You'll see why here in just a second. So this denominator is basically r squared. That's what Newton's law of gravity is. G m over r squared. Well, that's my expression of it because it's going to make what comes next a little bit easier. That net force on the satellite should equal the mass of the satellite times the acceleration of the satellite, which is a centripetal acceleration. And centripetal acceleration, as we've said several times now, is always equal to v squared divided by r, the radius of curvature of the motion, which in this case is 3RE. This expression I'm pointing to is essentially v squared over r, where specifically here, r is 3RE. Can we cancel anything? Looks like the mass of the satellite cancels. This 3RE will cancel one of those. And I think then the speed that this satellite is going to have is going to be whatever's left over here square rooted. So what would that be? G m e over 3RE square rooted. That's the speed that a satellite needs to have at that orbital radius. And you can see by the equation that the mass of the satellite is totally irrelevant. It doesn't matter if the mass of the satellite is 100 kilograms, 2 kilograms, 10,000 kilograms. It doesn't matter. All that matters is how far away we are from the center of the Earth, the mass of the Earth, and the universal gravitational constant. That's pretty cool.